Yeah, now we're going to look into programmable logic controllers or programmable controllers because they can do quite a bit more than logic. Logic is probably not, well, they're doing a lot more than logic, and logic is the least part of PLC program, or at least it should be. This combinatory logic, the ladder and FBD and things like that is not a modern way of programming anything, and it should go. So we're looking at this compendium, and now we're going to look at programmable logic controllers. Maybe make it a little smaller here. So it's hardware design for machinery, factory, and process automation. That's what it is. So it's programmable, reprogram it. Smaller, we have compact PLCs and so on. Here is this S7 from Siemens. This is the 1500 module-based PC with a variety of CPUs, and then you've got IOs and communication modules and power supply that you kind of construct a PLC in a rack. So this is kind of a legacy PLC or traditional PLC from Siemens. And Siemens, they have something called S7-1200 too, with these compact CPUs where you've got I/O on the CPU module and so on. So power for smaller tasks. Capability varies, of course, with the PLC. Yeah, as a PC. But what we're going to look at this one is what we call soft PLC, where this is what we call a standard computer or PC based on standard CPUs. Beckhoff use, for instance, Intel CPUs. You have got, so there's a Beckhoff, the CX2042, which is a 7-core Intel i7, I think, or at least a multi-core one. USB, you have network interface and DVI interface. You should move into HDMI interface and so on. And then you can have some other old proprietary interfaces you want to interface something. So this is what we call a soft PLC with a, let's say, a robust PC and industrial PC that can be used. Now for PLC, there is a norm standardization from an organization that's called PLC Open. There's a link down here, where they specify how a PLC, what a PLC is and how it should be constructed and so on. What we are looking at is programming, not the hardware, not so much. And communication, there's some fuzzy logic, application guidelines and communication interfaces and so on. This is the part 3 we are going to look at. So they have specified data types. You have a date type, time of day, and a string type, a boolean, integer, real word. Of course, the string and stuff in a PLC we don't use that often. A PLC can't read. We can, the PLC can't, and so on. And then you can make user data types, where you can have a collection of these, let's say, basic data types into a structure data type. So you have a collection of data, some boost and a byte and a word or whatever. A typical one would be, for instance, a floating point number and a quality code as a word. A word is 16 bits. Could be a structure if you want that. Because when you do processing and data is flowing through your application, of course you need to transmit a quality code along the data, so you know what you are looking at, if that's okay or something. You can have a structure, for instance, say for a 64-bit floating point number structure with a quality code. Doesn't have to be a word, it could basically be in a boolean, because in automation it's either good or bad. You can't work on bad values. Variables, input and output variables, and we have program element, function and function blocks. That's what we have. And there's a program too that's specified where you, let's say, program these function and function blocks, where you use them. And then you have got tasks too, which is the link to your operating system. And variables and so on. Global variables you should avoid as far as practical, because input and output to your PLC, they're usually global, even though they can be sliced a little, but in most PLCs, but whatever. Avoid global data. So what you have is that you have a configuration here. It's basically a PLC. And let's say, if you look at configuration, resource, tasks, and PO use. A resource, a task, a program. In the task and program, we have got FBs, function blocks, which is roughly equivalent to a class then in high-level language. Programming, and you have a communication function. We looked over, there was communication function too. So that's what is specified. And a function, if you have one, is used by a FB or a program. And the program is called, I use abbreviated PRG, program. As this is going to be Siemens programming, Siemens doesn't have a program element because Siemens, they're not following the norm 100%. So that's the program model. Resources, this is taken, you can find information on PLC Open. They have pretty much information about this. And they specified something called static data. So they can keep track of historical value normally as long as you have power on your PLC. So you use this if you need static data. A lot of applications you need static data. A function doesn't have static data. Okay, program languages. They have texture program language where we have got some assembly log programming. Of course, we don't use that. Here is multiplying two numbers, that's what we use. And Siemens, of course, does not follow this standard either. So they have the reverse Polish notation, load two numbers, multiply them and transfer them somewhere. Here's load, multiply with, and store. Don't use it. So what's the texture program language is structured text. Specified. Siemens doesn't have that, but they have something that's quite similar, kind of easy to port from Simatic, TI Portal to, for instance, the codices, that's fairly easy, and so on. Use that. This legacy assembly stuff, there's no need for it. And then you have graphical program language, FBD, function, block diagram, a ladder diagram. Avoid them. Yeah. But it is used in factory automation. So if you have to use them, use them. For modern PLC, there's no need to use them. It's just a legacy way of thinking. Start to think differently when you do PLC programming. So here's ladder, it's energy flow. These two contacts are closed. Then you got energy to your coil and a motor starts or whatever. And here's an OR. So there's an OR and an AND. Would look like something in FBD. Ladder is better than FBD because here you have to decode your logic. Here you can look at power flow, which is more intuitive. But in FBD, this is the German standard, you have to decode the logic. And if it gets complicated, of course, there are errors everywhere in here. And if you bring in memory elements, good luck. So sequential logic, combinatory logic, and memory elements. And then they have some sequential function chart that's based on an ancient French specification, or let's say Petri nets and graph set. Graph set is this French one. It's better because you can look at the flow in your program. But of course, final state machines, that's what you should use when you program sequences and so on. And then there is something that's not specified in this norm, which is called continuous function chart, which you should use instead of FBD and ladder, because this is kind of a UML-like tool. Let's say what's called uniform modeling language. You can use it like that. And CFC, in codices, they have CFC. Other program systems, ABB and so for the PLCs, they have something similar. And CFC, Siemens, they have got it too. So it's graphical configuration of your instances of function blocks that you have written in structured text. That's what PLC program is about. And of course, you have something called some basic operations like and, or, and not. This combinatory logic, you have to use it for something. You have to check the and between types and so on. Okay, this was a short introduction to PLC. We looked a little at about a Simatic 1500 range of PLC. I didn't go into text. I looked at the figure. So read this for yourself or use it as a reference. That's what this compendium is meant to be. And then there's a norm that the suppliers of PLC should follow. PLC Open and it's an organization. And we looked at the soft PLC and the standard PLC and the programming languages. And these legacy programming languages from the 70s and 80s, Ladder and FPD, maybe it's time to retire those. And they have to go down south and sit on a sunbed and have fun. So what you should use is high-level language, powerful object-oriented programming language, and CFC for configuration, or use structured text too when you configure your programming task. That's what you should